Picture the ground beneath your feet, not as something fixed, but as a lid. A lid on a pressure cooker that has been simmering, undisturbed, for thousands of years. On June 13, 2026, in a quiet corner of Yellowstone National Park, that lid blew off. Visitors near Biscuit Basin heard it before they saw it. A deep, concussive boom, like the sky had cracked open underground. Then came the plume, a churning wall of steam, mud, and rock, rising hundreds of feet above the trees in a matter of seconds. Nearby cameras caught it all. Seismic sensors recorded the shockwave, and when the steam finally settled, the land underneath it was gone, replaced by something that had not existed an hour before. This is the story of that moment. What caused it, what it left behind, and why the most misunderstood force on the planet had almost nothing to do with a supervolcano. Let's start with the blast itself. To understand it, you have to understand what Yellowstone actually is beneath the surface. Not a single sleeping monster, but a vast pressurized plumbing system threaded through the crust. Miles down, magma bakes rock and groundwater to extreme temperatures. That water doesn't boil the way water in a kettle does, because it's sealed in, trapped under the crushing weight of rock and soil above it. Under that kind of pressure, water can be pushed far past its normal boiling point and still remain liquid. Scientists call this superheated water, a liquid holding an enormous amount of stored energy, waiting for the right, or wrong, moment to release it. That moment arrived near Biscuit Basin. Somewhere in the shallow crust, a crack opened. Maybe a shift in rock, maybe a blocked channel finally giving way. It doesn't take much. A few feet of change is enough to drop the pressure holding that superheated water in check. And when pressure drops that fast, superheated water doesn't simply start boiling. It flashes, instantly and violently, into steam. In a heartbeat, a pocket of liquid expands into a volume hundreds of times larger, tearing through rock, soil, and anything standing above it. That is not a metaphor for an explosion. That is the explosion itself, a hydrothermal blast, powered by nothing more exotic than water-changing state, but with enough force to hurl boulders through the air and blanket the forest floor in mud and debris. It lasted only seconds, but it rewrote the map. When the steam cleared, the landscape was almost unrecognizable. Where there had been solid ground, trees, soil, a walking trail, there was now a raw, jagged crater, filling rapidly with churning, near-boiling water. Within 48 hours, that crater had become something entirely new. A hot pool, cloudy and blue-green, venting steam, and occasionally surging, like a slow, restless geyser. Ground that had sat undisturbed for centuries had been replaced almost overnight. Researchers moved quickly. Thermal cameras, water sampling, ground deformation sensors, all deployed within hours. Every reading brought a clearer picture, not just of what had happened, but of what it meant for the land around it. Was the ground still unstable? Could this happen again nearby? Was this pool a one-time event, or the birth of a permanent feature? What they found was, in its own way, reassuring. The explosion had released the very pressure that caused it. The system had let off steam, quite literally, and had already begun to settle. This new pool wasn't a wound still bleeding. It was a scar, already beginning to calm. Yellowstone doesn't erase these events. It absorbs them. Scattered across the park right now are craters and pools that were once violent blasts, just like this one. Decades or even centuries old, now looking as peaceful and permanent as if they had always been there. This is simply the newest one, still finding its shape. The moment footage of the blast reached the public, the question on everyone's mind was the same. Is the supervolcano waking up? It's an understandable fear. Yellowstone sits above one of the largest volcanic systems on the planet, capable, in the deep past, of eruptions that reshaped continents. So when the ground explodes on camera, the mind jumps straight to the worst-case scenario. But here is the distinction that matters most in this entire story. A hydrothermal explosion and a volcanic eruption are not the same event, and they are nowhere near the same scale of danger. A volcanic eruption is driven by magma, molten rock forcing its way toward the surface. What happened at Biscuit Basin never involved magma at all. It was water, superheated and pressurized, reacting instantly to a small drop in pressure a few hundred feet underground. It's a shallow, localized event, dramatic and genuinely dangerous up close, but geologically unrelated to the deep magma chamber that defines Yellowstone as a supervolcano. In fact, this kind of explosion is not rare. It is one of the most common geologic events in the park's history. Yellowstone has produced hundreds of hydrothermal explosions over thousands of years, most too small to notice, a few large enough to leave craters that still exist today, quietly filled with water, mistaken by visitors for simply another scenic lake. Every measurement scientists took after the blast, ground swelling, seismic activity, gas output from the deeper system, showed no sign of broader disturbance. The vast system underlying the park was behaving exactly as it does on an ordinary day. The explosion was real. The drama was real. But the fear of an awakening giant, that part was never true. What happened at Biscuit Basin belongs to a different chapter of the same story. One written in water and steam, rather than molten rock, and one that plays out on a timescale of seconds, not centuries. So if the deep system stayed calm, what keeps it that way? Why doesn't all that heat and pressure simply build until something far worse happens? This is where recent research adds a piece most people have never heard of. Roughly 2.5 miles beneath Yellowstone, scientists have mapped a layer of rock that behaves unlike the solid stone around it. It's porous, riddled with countless tiny spaces, like a sponge made of stone. And that structure changes everything about how the system breathes. Volcanic gases rising from the magma below don't slam into a solid ceiling and build unchecked pressure. Instead, they seep into this porous layer, spreading out, slowing down, and gradually working their way toward the surface in a steady, controlled release, rather than gathering into one catastrophic buildup. Think of it as a pressure valve, built by geology itself. Not designed, not maintained, just an accident of rock formation, sitting exactly where it needs to be to keep the whole system in balance. This layer is very likely part of why Yellowstone has gone thousands of years without a major eruption, even as heat and gas continue rising from below. The pressure that could, in theory, build toward catastrophe is instead being bled off slowly and invisibly, one bubble at a time, through solid rock that happens to be full of tiny holes. The explosion at Biscuit Basin was a small, sudden release in the shallow crust, the kind nature handles quietly all the time. The porous layer 2.5 miles down works on the same principle, at a scale that protects the entire region. Two systems, two safety valves, working in their own way, every single day. What happened on June 13, 2026, looked like the opening scene of a disaster film. A sudden blast, a smoking crater, a brand new pool where the ground used to be. But look closer, and it becomes a story about balance, about a landscape constantly venting the pressure inside it, in ways both dramatic and invisible. So the truly catastrophic version of this story stays exactly where it belongs, in the distant past and in the distant future. Yellowstone isn't a bomb waiting to go off. It's a system that has been quietly managing its own pressure for millions of years, and every so often, it reminds us, in spectacular fashion, that it is still very much alive. Somewhere beneath the trails and boardwalks, that same slow breathing continues right now, patient and unseen, the quiet mechanism behind one of the loudest moments the park has produced in years.